language models, it seems like the opportunity has come to us to fulfill that mission truly. If you think about it, right, these days, a lot of companies are adopting large language models, but there is obviously, the previous speaker outlined the big wins that companies are able to make, early wins, obviously. But here I'm here to talk about some of the risks and oversight needs that you need to take care when you're deploying these large language models. And we believe that AI observability is essential to really unlock the full potential of these models. So let's start with what's going on actually. This is histogram from Andreessen Horowitz, one of the top VC firms in Valley. And this is a few months old actually. But if you see, like, there is two bars here. There's a green bar that highlights companies and basically teams that are testing large language models, and the blue bar indicates the productionization. You can see across all these different model providers how these LLMs are being put into action. And we hear, from our own perspective, lots of different use cases. Now, some of the use cases were covered in the previous session, but for example, one of the leading car manufacturers in the world is actually putting generative AI to simulate a lot of experiments so that they can save costs on physical world, and they can actually run this more efficiently. A couple of major banks have put in generative AI for fraud detection. Actually, yesterday, MasterCard blogged about it, how they're using generative AI for fraud detection, anti-money laundering. They're able to see big wins in those areas. And then there are virtual assistants being deployed from a sustainability point of view, where they can save the carbon footprint and so on and so forth. So a lot of innovative ideas being pursued by industries across different verticals to deploy these large language models. However, we are also seeing the other side of it. We are seeing AI failures happen that have hurt the brand reputation of some of these companies, that have made some of these companies incur some financial losses. The most notable ones you may have, pretty much probably everyone has heard about this Air Canada's hallucinating chatbot, which just happened a few months ago, that provided incorrect information to a passenger at a critical time, and it became big litigation, and it caused severe damage. There are also various different cases from chatbots that were jailbroken. This was a delivery chatbot. Some user jailbroke into it and made it utter abusive comments, and was tweeting about it, and sort of an embarrassing moment for the company. And there were events basically there's a Willy Wonka experience that went wrong for a children's event due to a LLM hallucination. There were universities apologizing for the misrepresentation of companies through their LLM applications. So there's basically a lot of these things come down to the various risks when you actually are deploying large language models, right? So here are some things that we constantly hear from AI teams that we work with at Fiddler. Performance, how is the model performing at any given point of time is a huge concern. Quality of data, large language models can query your unstructured data, and how is the quality of data? Do you have the right recall and coverage for all kinds of questions that your AI assistants can ask your LLMs? How safe are these LLM outputs? Are they going to be toxic or abusive or racist? What's the cost? What's the ROI? And correctness, hallucinations is a big problem, right? LLMs have this world knowledge baked into them, and they can always come up with an answer with whatever question that you ask, whether it's relevant or irrelevant. Transparency, robustness, security, whether they can leak pre-API data. All of these are big risks. Now, this is where we believe that oversight is going to be really essential, right? So you can think about a couple of things here, right? So think about hallucinations. How are you going to make sure in an automated manner that your LLM is performing in faithfully to your data, right? It's not making up things, and it's not guiding the user in an incorrect direction. This is a very hard problem, because only way to do it reasonably, it seems like, is to put a human in the loop, right? A human in the loop that can verify it, but how is it going to scale? How many humans are you going to deploy to look at these LLMs? And so the key is going to be, how do you automate this thing? And we're going to talk about some of the approaches here that we are developing on the technical side to catch these hallucinations in an automated fashion. Security issues, jailbreaking activity, where users can write different types of prompts and hacking to your conversational assistants to make them either elicit private data about your company or make it utter toxic responses. And this is also bad from a reputation perspective, from a regulatory perspective, and then safety issues, where you can have LLMs produce biased responses. So this is why you can see that there is a lot of effort being put across countries in terms of developing regulatory guidelines. And if you study some of these regulatory guidelines, they all talk about this constant oversight, continuous monitoring of models. In fact, if you see the AI Safety Executive Order that is going to be in place for government agencies this year, they actually have mandated monitoring of these models for rights impacting and safety impacting models. So you see this EU AI Act, they categorize these AI applications into high risk, medium risk, low risk, and then basically mandate different types of oversight techniques, explainability, model monitoring. So all in all, what has happened is in the enterprise there are a few LLM standards like trust standards that have emerged. It's important for enterprises to ensure there is secure data retrieval. There's obviously your proprietary data is super important for companies, and how are you going to make sure that these LLM applications, whether closed source or open source, are respecting the data security policies. Dynamic grounding, this is the hallucination thing. How do you make sure that the responses are accurate or correct and relevant? How do you do it in a dynamic manner? How do you make sure that you're masking your PII so that it's not actually going to the end users or even employees that shouldn't have access to them? Prompt defense, how are you going to make sure that you're preventing any jailbreaking activity and create a defensive layer for your AI assistant so that you're not actually sending some of these prompts to your backend systems? How do you detect toxicity? How do you make sure you're creating audit trails and creating like a zero data retention, especially when you're working with vendors? So these are some of the standards that have emerged. And what we have seen is, in order to address these problems, there's like a new stack that has emerged in the last year or so. We call it the mood stack. We're kind of creating an acronym here. So obviously there are 4 layers to this mood stack. There's obviously the data layer, where you keep your data, store it, transform it, warehouse it. There is a whole bunch of services and infrastructure pieces here that one can use. And there's modeling layer where there's a plethora of choices, from closed source models to open source models. Open source models are gaining a lot of traction. For example, if you've seen like what happened with Llama 3.1 this week, it's coming very close in terms of accuracy to the closed source models. And then orchestration systems that can help you combine these models and data sets and your business critical data and create a workflow for your LLM application. And then observability. So Fiddler has been working on observability with other observability tools as well here, there, where you could actually plug in to monitor these different LLM applications and ML models that you're building. And so this is basically the stack that is emerging that we are seeing in many enterprises that are getting deployed. It's almost akin to that. If you're old enough, as old as me, there used to be this LAMP stack when the internet came of age, and where people would use Linux, Apache, Memcache, and sort of PHP to build these MySQL and PHP to build these web applications. So it's similar to that mood stack. So what is AI observability at the crux of it, right? So AI observability is a set of processes and tools that help you evaluate your models, monitor them in production runtime, and help you protect your LLM applications. At the core of it, AI observability is about being able to measure your model performance in an automated manner, measure accuracy, measure safety, measure the quality of it. And so if you can have these metrics available, and you can actually then use these metrics to evaluate them pre-production, where you're designing the LLM app. So maybe you're designing a customer-facing chatbot, or you're maybe building a help desk application for your business, business users, or you're helping your customer support team summarize, call center logs. In either case, you need to think about how your LLM is working, how you need to evaluate it, and then when you put it into production, monitoring it at scale, ensuring that you have some alerts in place when things go wrong, and you have ability to do root cause analysis, and then finally protecting it, where you can have a guardrails layer where you can actually create that prompt defense layer, so you're not actually subjecting your assistants to the real world without any security issues. So this is basically how one can think about this AI observability, right? So if you're familiar with like traditional observability, like if you use tools like Datadog or Splunk, they have pioneered this notion of logs, metrics, and traces. So if you apply that analogy to AI observability, it pretty much can fit in, right? So what would be the equivalent of logs in the case of AI observability? These are the inference logs that your models are generating. These could be the prompts, the inputs that you're giving to the LLMs, and the responses that are coming back with it. Any other metadata. It could be the embeddings. So all of this could be the logs that you could store and actually feed it to an observability system. And then observability system can calculate these metrics for you around drift, data quality, safety, privacy, and then help you visualize these things. So you can do root cause analysis. So you can actually create a report around how the model is performing. You can actually do segmentation analysis. So how did the LLM do on these users versus these other users, or which prompts are actually suffering from hallucinations, which prompts are doing well. You can do all of those things. So I'm going to show you how this looks like in a bit. Basically what you want is an all-in-one platform that can essentially help you do this, really like understand the model behavior on a collective basis, and also help you go into a fine-grained way and explain these individual predictions. So how would an observability system look like at the end of the day, right? So if you have these metrics, you can create a dashboard like this, where, let's say I'm a bank, I'm building a chatbot using, let's say, Azure OpenAI. Now I can observe that chatbot, in near real time, where I can say, what's like my toxicity rate? What's the hallucination rate of this chatbot? But the key is, how are we going to compute these metrics? And that's where I'll spend some time. And we call it these trust models. This is a new innovation that's happening in the industry. And so the trust models are basically, think about these are small language models that are essentially evaluating your LLMs. And so these are like, models that have, maybe 100 million parameters or so not very large models. And they are fine-tuned and they are very task-specific. So you can have a trust model that looks at the source, context, prompt, and response, and it can come up with a hallucination score or a faithfulness score, saying that how close is the response to the source context. Is the response derived from the source context or not? Or you can have a trust model that can actually detect toxicity issues in responses, where you can say, is this response having inflammatory information or racist content or any brand safety violations. So you can build these trust models, and then the trust service can score these in real time. So when you actually have a prompt and response sent to it in real time, you can actually come back with these metrics. And so once you have these metrics, then you can create a diagnosis workflow. You can create a reporting workflow for your users to understand how these things work. And this is actually happening industry-wide. The beauty of it is you can create these trust models on your own for your own custom data. So if you have PII information that is very relevant for your industry, you can create this. This is actually becoming a trend in many companies in terms of building guardrails around the LLMs. And the way these trust models would work is you would send it basically the payload of these prompts and responses. So for example, let's say imagine a company that's building this chatbot and is getting these prompts and responses. Now you can actually constantly receive this feed of prompts and responses, and you can create this workflow of calculating all these scores. Calculating the toxicity score, faithfulness score, jailbreaking score. And all of these scores can then be stored and visualized. So like essentially visualize like in this kind of dashboard. So you can have like a diagnosis workflow created out of these scores. So once you have these trust models, what you can do is you can actually accelerate your deployment of your LLMs, right? You can actually make sure that your RAG chatbots are observed continuously. You can actually make sure that these trust models can run in a cost-effective and low latency manner, where they can act as guardrails and can protect your chatbots and make sure that you are monitoring continuously. So I would divide the metrics that you want to monitor into 3 or 4 categories, right? So firstly is your hallucination metrics, and there can be n number of ways to measure it. There's relevancy of the model, there's coherency, there's basically the faithfulness we talked about, and then there's a whole bunch of safety and security metrics. Then one needs to take care about, how is PII activity? Is it, how are you measuring jailbreaking activity? What kind of are you actually having some brand safety? Most of the companies, when they put out these AI assistants or chatbots externally, they don't want their competitor brands to be uttered by these chatbots. How do you make sure that you are catching those things? And then operational metrics. LLMs are not very cheap, so GPUs are not cheap, so you want to make sure that you are monitoring the cost, latency, and the operational metrics in these things. So all in all, what you can do is with AI observability, you can create this live reports and dashboarding on how these LLMs are working across these different metrics and drive that business impact. And here, what you can do is you can actually customize these metrics, whether it's like brand credibility or marketing insights, or you can have different types of these trust metrics that are available for you. Anyway, so finally going into this, we are working with a large set of enterprise companies here. We're happy to talk if you have more questions. We believe that AI observability is fundamentally very, very important for you to productionize LLMs in a safe and responsible manner. And we are happy to share our insights. I've been working on this problem for a few years now, and very excited to be here. Thank you so much for the opportunity.